Hello, everyone. I'm going to wait for people to file in. If you are coming into the chat, please make sure to drop by hello and where you're from. This way we can give everyone a few minutes. Hello, Robinson and David. Oh, hello from Kenya. That's cool. And the UA. In fact, if anyone who's in chat, just kind of give me a sense for what your experience is with either infrastructure as code in general or Terraform or Pulumi. I'm kind of interested on what we're going to be working with today. Hello from Majid from Egypt, and hello from Berlin. That's cool. Hello from Dusseldorf, and Argentina and Bulgaria and Turkey. We have a lot of people in today. That is awesome. Okay, what did I miss while I was trying to type some stuff? Argentina, Bulgaria, Turkey. Hello, everyone. Hello, Belgium and Dublin. Yeah, I'm also more familiar with Terraform than I am with Pulumi, but when I was using it the other day, it was actually a pretty pleasant experience. Hello to Iowa, and Rhode Island. Even more people from Belgium. Got a lot of people from Belgium today. That's nice. South Wales. That's cool. Yeah, my experience personally with things like infrastructure as code and Terraform specifically, I used to be a cloud engineer for a migration consultancy, and we would use a lot of Terraform, usually for doing architecture deployments for clients and stuff. And I'll be honest, when I started in just cloud engineering in general, I'm an application engineer. And I've said this before, anyone who showed up on my serverless chats, I don't like infrastructure because I find networking hard. But when I started with infrastructure as code, it really kind of solidified what it looked like more than any book or tech talk did for me. I have a lot of people among my family and friends who are in the hardware and networking and infrastructure space. That's not me. That's not a thing that I enjoy, but infrastructure and code really abstracted things in a way that I was able to understand what my application was actually doing. So I think in a way it's really important for application engineers specifically to learn infrastructure as code, just so that they know how their application is behaving amongst things that they generally would not touch. So tell me about your opinions on that too. And hello to Brazil and Nigeria. How much time has passed? About 5 minutes? I'll give everyone maybe just one more. see where you all come in. Yeah, that's how I got started with Terraform specifically. And then when I was working on AWS stuff, I did a lot of, I moved directly to CloudFormation, and I also used a lot of serverless framework because, again, if you've been to my other tech talks, I'm more of a serverless engineer than an infrastructure engineer because, again, don't like it. And I like those frameworks honestly better than Terraform. You'll find you have a lot more control with the IAC language that is specific to the cloud you're using than you would on a third party, but a third party will do a better job at abstracting things in a way that makes similar concepts between clouds work together. So if you're either a generalist engineer or you're in a hybrid cloud setup, your chances are you're going to be working more with a third party anyway. Excuse me, everyone. My throat is still getting better. Hello, Brazil, Canada, and Bangladesh. Okay, I think I've talked about enough about me for a second. And so let's get into the topic at hand. If I know when I get a little bit excitable, I talk a little fast. So if you want to follow along, or you want to try any of the definitions that I start talking about, or you want to read up on the articles that I'm going to cite, you can go into this GitHub. There's a list of resources there. There's a list of prerequisites of what you have to do before you really get into what is happening with the code that's going to be on my screen. If you want to see the code itself, it's all going to be there. So go check that out. And then we'll get started. So this talk is specifically going to touch on GitOps. We're going to talk about infrastructure as code beyond my own personal experience, what it actually does. And then we're going to compare and contrast Terraform and Pulumi. I am going to build a couple of things. I'm going to show you some things that I've built in the console, and also how to build the exact same thing using Terraform and Pulumi, and what the difference is in what that looks like and what that definition is. Just let me set something up before I forget. There you go. Doop. Load screen. There we go. All right. So first, let's talk about GitOps. GitOps is a term that I've only heard in the past couple years, but the concepts that they talk about are very traditional in nature. It seems to be moving away from the more vendor-locked type of deployment, not just on your cloud provider, but also the kind of frameworks you're using, the kind of pipelines you're building. So according to, I believe this definition is from DevOps.com, GitOps is a way of implementing continuous deployment for cloud-native applications that focuses on developer-centric experience when operating infrastructure by using tools that developers are already familiar with, including Git and cloud deployment tools. GitOps opts for building and testing off of diffs using merge request-based deployments, and this differs from the quote-unquote traditional CI/CD models that use a push-based system. So the reason why I put traditional in quotes, because I already use the word traditional. When I say traditional, and please remember that I started 15 years ago, so I'm talking about when we were still on Subversion and doing runways and that type of similar things. While you can still do GitOps using Subversion, If you're in an organization that is using Subversion, Subversion has its place, especially if you're in a large, rigid, trunk-based type environment. Subversion works real well for that. In fact, that is where it hit its stride. GitOps is more about the process of being able to observe changes and build when that observer sees them. So I'm going to switch out of this for a second so that you can see what I'm talking about. This is from GitOps.tech. Again, all of these articles are in that linked in that GitHub, so you can go see it as you need to. Let's see, there was a good image here. So this is a pull-based deployment, which is what GitOps really focuses on, where it has a third-party resource right here. Let me see if I can zoom this in a little bit. Use, zoom in. Right. Where you have this operator here, instead of it only building when it senses a change in the image registry, it checks for changes on both, and then it does its own type of reconciliation where it writes here, and then it will observe any changes in deployment, and it will deploy those changes just to make sure that everything is synced up. The repo is not available. I am so sorry. Let's go fix that, because I do want everyone to have access to this. Okay, setting. Oh, I know why. Okay, I know why. It's a personal problem. It is because when I build stuff, because I'm one of those people who adds a repo whenever I have an idea at 3 o'clock in the morning. So I tend to set them to private so you don't actually see what that mess looks like. So we're going to make that public right now. Wikis, issues, button. Okay, change visibility to public. I don't know what my password is. Give me a second while I find out what my password is. I am so sorry, everyone. This is the one thing. When you test things, make sure you test it in an incognito window, just so that you don't do what I'm doing right now, and that is changing things on the fly. There we go. Please try again. Tell me if that helps. Okay. So in the meantime, I am going to continue. Let's see. But yeah, so that is the focus of the deployment, is that you have this separate system within your environment that is able to change it. So that's the important part of GitOps, because that allows the ecosystem to be more aware of the application than it is of the environment it's in. And that's what you want. So while you'll find a lot of documentation pushing the idea of a pull-based or merge request-based deployment system, according to David Flanagan, on this tweet, the tweet is also cited, is that it isn't that you can build a GitOps environment on a push or pull type of delivery system. It's more about making sure that the environment tells your application how to run, or whether or not your application tells the environment how to deploy itself. So that means I misspoke earlier. You want the latter. The latter is GitOps. That means you want the environment to tell your application how to run. And according to this post that he made for Pulumi, as an industry, we're seeing a great deal of momentum towards platform engineering. And with this comes a broken divide, a strict division of responsibilities to build a platform and to consume a platform. Instead, the platform will provide everything the application needs to function. So what this essentially means is that the tooling that you use in order to do the deployment should handle whatever it is you're telling it to handle, instead of having it be a bit of magic-based deployment things where you can't really control what's happening. You tell it, it's like, I need you to do this in this order like this, and it will do it. And the platform itself should be aware enough to be able to handle all of those requests. Yes, if you want, you can. If you don't have access to that repo, you can use my personal repo, and I will go check out the other one and see what is up with that. I'm actually going to change that on the banner for now, just so that let me. So I believe that should work. Let me validate. That's not my username. Haha. Sorry about that. Do you ever type something so much that it loses all meaning? That's what's happening. Okay, there you go. That's where mine is. That's public. That's tested. You can go try that. So infrastructure as code, which is really why we're all here. This is one of the tools that makes GitOps and really any good deployment system possible. It is a definitive way of automating cloud resource deployment, which means you can build out code, or you can create a configuration file, and it will build and update the infrastructure as necessary. So this uses two approaches, declarative and imperative. Declarative approach defines the desired state of the system, including what resources you need and any properties they should have, and the IAC tool will do it for you. This is basically going to show up as a YAML file in any version that you do. Alternately, you may have a JSON file or XML. Let's hope it's not an XML file, but that is entirely possible. It's a list. It's a qualified list of what you need, and it will do it for you. And because of that, it also keeps a list of the current state of your objects, which makes taking down the infrastructure simpler to manage. It will also create other problems, and I will explain those later. An imperative approach defines specific commands needed to achieve the desired configuration, and those commands need to be executed in the correct order. When you are using an imperative infrastructure as code, what you're generally going to see is either a runnable script or a class. So you're going to see executable code, and that's what they mean by they. Of course, they have to be executed in a specific order, because that's how the program is going to run. If you are seeing code, it's going to be imperative. If you are seeing a YAML or a JSON file, that is going to be declarative. That is the shortest version of how it's going to look. So what is Terraform? As I asked earlier, a lot of us have more experience with Terraform than we do Pulumi. Terraform is a declarative infrastructure as code framework. It uses its own proprietary language called HCL. It looks It looks and acts a lot like YAML. It all and those files will be used as its own personal configuration files. The problem I have with Terraform specifically is that because the way it works is that you write out this configuration definition. Terraform does its thing, which is interprets whatever that definition is, depending on how the provider is built, and then it makes API calls, which is great in that you know exactly how it's going to work and you know the path it's taking. But also, the biggest problem with that is that you have to manually manage state, and I will show you what that looks like right now. So when you're manually managing state, you have these log files, which includes all your versioning, and let's see, TF state. You have a TF state file and your backup, which will have all of the times you have actually built it and your full definition. If you mess this up, your entire stack becomes corrupted. So be very, very, very careful. So yeah, that's the thing that I'm not a huge fan of, because that means it's great if one person is working on it. If there are multiple people working on it, there are things you have to do in order to manage that state, which I'm sure there have been better solutions created since the last time I used it, which was a couple of years ago. But what you generally had to do back then was create a transactional table and store all of your state that can be synced up to the next person who is going to be using it. That is not the best way of doing things. It is very complicated. It is also prone to error. So if managing state is something that you really have to figure out, I would, and you're still in the area of being able to find alternate solutions, maybe look around to see something that fits your needs better. When I was using this was really the strongest contender for an IAC language that was cross-platform. So that leaves Pulumi. What is Pulumi? Pulumi uses an imperative approach, such as infrastructure as code. You can use any level of languages. I shouldn't say any. You can use a lot of languages. You can use the biggest ones like Go, Python, Java, Node. It also allows you to use declarative YAML if you just want to do definitions. It does require a Pulumi account, but that state is going to be managed by the Pulumi's dashboard, which is a nice feature that you have to pay for on Terraform. So to me, that is the biggest differentiator. Also, if you have to cross-train people into doing their own infrastructure definitions, then it's easier to use a language they're already familiar with than attempting to get buy-in on trying to learn HCL, which is very specifically only for HashiCorp products. So if you are outside of the SRE team, you will never use that language outside of the definition that you're turning in. And yeah, that is my biggest issues with IAC. So we're going to start looking at code soon. So is just checking in. Are there any questions so far? What are your opinions of the infrastructure as code frameworks that we presented so far? Is there anything so far that we can kind of clear up for you? Also, if you're following along and you're just good with what we're doing, just drop a thumbs up or some other emoji in chat, and then we'll know to continue. There's some emojis from Twitch. Twitch always has, I keep forgetting that Twitch has its own emoji library, which is amazing. As a developer, Pulumi has felt much more comfortable than Terraform so far. I agree. I've used Terraform a lot, and I've only used Pulumi a little bit, but just getting onboarded was so much easier than I think Terraform is. Hi, Otto. So everything's good for everyone? Cool. Yeah, I personally enjoyed Pulumi the little bit that I played with it just now. I remember my first experiences with Terraform and not understanding that state issue coming out. It was difficult. It is a learning curve, but it is also a standard language across these types of um, roles. So it's something you may have to learn eventually. Also, if you're not an SRE, the priority to learn it is much lower. So, going into the demo, one of the things that you do have to have in order for the demo is a DigitalOcean account, because that's what we're building on today, and a Pulumi account because, as I said, it manages stuff inside of the dashboard. Okay. As far as SDKs, you can both Terraform and Pulumi have installation instructions on how to use it for your own specific system. The system I'm building on right now is a Mac, so I was able to homebrew everything in 3 commands. It was super easy and super clean. So it is a hard requirement to have a Pulumi account to use the tool, because when you try to when you build your definitions and then you attempt to do a plan for it, it will ask you for the key for it. The Like most developer tools, there is a free tier, and I'm not sure what the pricing is when you want to onboard it as part of your commercial pipeline. But it is, in fact, it is a hard requirement. At the very least, very tied into their CLI workflow. So if there's a way around it, I would love to hear it. I mean a real workaround, like I missed a command or something, not if you do some sketchy things, then we can all kind of skirt the licensing issue. Let's all follow the license, please. So but I was able to sign up for an account for free and be able to use it and deploy a few things. I did not do a deep dive on what those limits and billing practices look like. Terraform has a similar system that is not required, which is why a lot of people start off with it, where Terraform Cloud is a paid service, but you do not need it to use Terraform. But it is a thing that also does the important things, like managing state and identity. Because otherwise, as you're going to see when I do my demo, the identity part can be kind of problematic if you're not careful. It's one of those things. Remember, everyone, general rule, don't check in your keys. Yeah, you don't need Pulumi infrastructure. You just need it to register so that it can read into the dashboard for state management. So, okay. And now we're going to leave that window and we're going to go here. So this is what the repo looks like. I'm going to start off with Terraform because it's the one a lot of us are more familiar with, if that is okay. So let's go to Terraform. Of course it's going to be like that, you can't actually see the command because of the bubble. I'm going to take the bubble down, but I will put it back up after the demo portion of this just because it's covering up my command line. Okay. So as I mentioned before, you're going to see a main file and a state file. And going into here, your main file is going to look like this. This is going to be your overall definition of your infrastructure, which one of the things that it does is that it will also read other Terraform files in the same level. So if you need to have different stacks for different applications, that is one way you can organize it. I believe they also now have an option for policy as code. Before the main option was cloud custodian. So what policy as code does is make sure things that one, you obviously have the permission beforehand to deploy things. It also makes sure that if you have required tagging, which is important for so many attribution reasons, mostly monitoring and cost management and security. So, and make sure you have all of that in place. That is extremely important, and we should actually probably do something about that later. I'll bring it up. We'll do something about it later. But for now, we're going to go look at this file. So as you see, here's the DigitalOcean provider we're going to use. This is going to be the library that when we do the definitions, it's going to read that and then make the appropriate API calls to build whatever it is we're building. And then you need to define variables within the configuration file, even though we also have to declare it inside the command line. That's when I said the identity portion of this does get a little problematic as far as building it, but we make do. And then because we defined it here, we're now going to put our token there. This is just an API token. There is a different video up on YouTube to do API tokens on DigitalOcean. Or you can just go through our product documentation and you can find it. But because this makes API calls, it requires an API key. As opposed to Pulumi, since you are already logging in, that acts as your credential. This acts as that credential. So this is the definition of our droplet. This is our image name. It's going to be Ubuntu 22.04 with an x64 CPU, 4 virtual CPUs, 8 gigabytes, right? This is our region. This is our name. Basic definition. And then we're going to do a firewall. If anyone's curious about how I chose these definitions specifically and what these rules are, it's because I followed the DigitalOcean tutorial on how to make a production-ready droplet. So it's only going to have 2 resources. But for our purposes right now, where we're just looking at what the definitions look like and we're comparing them, it's going to work for a problem. Oh, let's not add stuff. There we go. Whoop. What? Huh? So I don't know what I did. That's probably fine. But hold on. Everything's fine. Okay. So this is going to be our firewall. This is how you do firewall rules in Terraform. You have an inbound rule. It has all of that. It has your IP range. Don't do this. Do not do this in real life. Please lock down your IP addresses to what your IP address actually is that's going to be dialed into a server. This is going to be up for all of 2 minutes before taking down again. So we're going to be clear for now, but if you're going to do this, make in practice, especially on your own personal account, especially on your work account, make sure that you choose the IP address range that is appropriate for you. That should be the address you are working from and the address of anything that you are going to be connecting that should be connecting to this machine, and those addresses only. Do not leave it open like this. Okay. Let's see if we can zoom in on this a little bit more. View zoom. I can't. This is unfortunately as big as. No, that's as big as I can get it. That's unfortunate. Right. So that is the file. When we build it, it's going to again, I showed you this before, but I'm going to go through this one more time. This is a list of hashes. This is how it can tell that the stacks are valid. If any of these get messed up, because it's a log file, it will corrupt your stack. If you have a corrupted stack, the only option is to delete it. And when you do, you take your entire stack down. Again, this is like the dangerous part of it. But also, if you are working with multiple people and you do not use Terraform Cloud, one of the things you have to do is build a transaction table that you can sync from in order to make sure that you're all sharing the same state. Because the hashes do not record as part of the hash where you are, what account you are producing it from. It's only going to be at the stack itself. With that said, if you mess it up, it gets messed up. Oh, that's a log file. This is a state file, so it's that. So just be very careful when you are managing state. Make sure you sync up both files so that everyone has the right files with you. Let's see. Yeah, so we're going to build this real quick. Okay. Yes. So initially, just so you know what it's supposed to look like, this is a droplet that I built where I got those specifics from earlier, except the only difference is it's an NYC and not SFO. So this is the droplet. You can see all of our addresses and everything there. And create. Where's networking? Well, we'll go into networking. Firewalls. That's going to be our demo firewall. And this is the same ranges that we went over. So that you can read that better. This is all of the ranges that we went over in the Terraform definition. Okay, so we're going to build the exact same thing, and we're going to do it in Terraform. Yeah, that's fine. I'm going to do this the purely professional way, just hitting up until the command comes back so that I don't have. There we go. I don't want to destroy, we want to create. Okay, first. That's fine. Okay. Terraform. When you hit Terraform plan. Okay. I didn't know I had to do that. Okay, yes. So remember, it's now looking for a variable that we still have to put in, but I don't want to put it publish on this video what my API key is, so I'm not going to do that. Let's see, where was that command, which I probably should have saved. There we go. So in order for the Terraform file to fill out that empty variable that we had, instead of directly referencing it from the command line, we had to build another object. This is what's going to populate the value for that object. So when you do a Terraform plan, it's going to show you the entire definition, including the fields that you did not fill out. Okay, hold on 1 second. So Terraform now allows you to share state in AWS S3 and Azure Storage for collaborative work. Okay, that is the process that I described. No, wait. When we did it in table, but you can also do it as a state. We did it as a document. We put it into a document DB, I believe. But it's essentially the same process where you are syncing against either a previously existing state that you manually upload. And since you have to do that process manually, unless it is part of an automated process that's built into plan and apply, then chances are, if you don't have Terraform Cloud, you still run the risk of potentially corrupting your own stack. I would love that to not be true, though, because that has happened before and is depressing and bad. So this is what a Terraform plan looks like. It's going to do a create. It's going to tell you what it's going to do. If you have any updates in your stack or deletions, it will also list them here. It's going to create this entire resource. It will know all of this metadata after I hit apply. Same thing with the IDs. It's going to know it after it applies. When you make a change later, it will update all of that information with the most current, with whatever metadata is attached to that resource. Then you have your, excuse me, your inbound rules, your outbound rules. So that has the two states. You can also print, if you are concerned about whether or not this is a good idea, you can also just save your plan with the output option and then share it amongst your team and get a bit of validation. That helps. It also helps if you're doing a lot of collaborative work to have a process where if you're going to run any of these changes in production, it is always good to have someone else's eyes on it, because you can look at the same thing forever and then it will stop making sense. Okay. But for now, we're just going to hit apply. So again, we do have to pass that token because it won't let us just pass it directly to the file and it won't read a separate file for it. So Terraform, apply. And then we're going to watch it. When I did this last night, it only took a minute. Yes. Yes, please. I do appreciate that it asks, but then I'll forget that it asks. And I'll be waiting for me to click the button. Well, when I did this yesterday, it took a minute. So hopefully it does not take much longer than that. So we'll see. Let's check in on chat while it's building. So There. Yay, less than a minute. That's awesome. So now we can go see what that's going to look like. And then we will go look, manage droplets. And now we have our Terraform droplet. It should look exactly the same. IPs, everything, networking. Same, it's on the VPN. Here's our firewall. Our firewall is attached and all of our rules are there. Great. So that's been deployed. I'm going to destroy that because I don't want it hanging around. So we do that with the same command. Now we're going to do destroy. Yes, destroy all resources. And as I said before, it's going to run that destroy command. While it's doing that, I'm going to show you what it all looks like. Destroy, and then it's going to just null all of this out and then push it so it all goes away. Much faster to destroy things. This also helps that we are not actually destroying the default VPC because one, DigitalOcean comes with a default VPC, but also whenever you do work with VPCs, it's going to take much longer. Just so you are aware, it's not going to be a minute. It is going to be several minutes. So now we're going to go look at what Pulumi looks like. There we go. So when we're looking at Pulumi, you'll notice one, much fewer files, and two, there's one YAML file and one Python file. And everything else is just supporting files like your requirements, your cache, and your POM. When you do a build, the POM, cache, and your POM and your cache will get automatically generated. Really, and when you authenticate with Pulumi, it will also build your Pulumi YAML. Or you can build that ahead of time. So that's one of the options that you have. If we're looking, the one file that I did build, where did it go? It's all there. Come here. So the one file that I did build for Pulumi is the main file. And the main file is, it has to be either named main or setup, I believe. But once you do the imports, you're able to create it as if it was an object. So you create this droplet, and then as you create the droplet, you also create it as an object like that. You can create the firewall similarly as an object like this. Again, same rules as last time. We're going to keep everything the same as much as possible. So that's your firewall. That's your droplet. Our name is going to be Web Firewall and TikTok Pulumi Droplet. Well, TikTok Pulumi for the droplet. So we'll go see. And once I did skip the authentication step on this just because I wanted to have this already set up and have the authentication done, so we're not watching me trying to remember passwords again. And installs. But remember, all of that is going to be as part of the installation instructions anyway. Okay, create new stack. We'll call this dev. Yes, let's perform this update. And that's what that process looked like. That happened much quicker. It happened much quicker because it failed. Why did it fail? Okay, post, unable to authenticate you. Okay. This is literally why I made sure I was authenticated before. Okay. I think it's Pulumi Auth. Anyone remember the authentication? Let's see. I know I'm running a little behind, so I want to make sure that all of this gets done. Up, version, create, new org policy. Well, that's not helpful. I know. Really, where's the authentication? Okay. Whew. Fun times. Love building stuff live. So yes, I do know that it sees me, but it won't authenticate me. That is weird. Okay, let's go check on. Let me check my account status. Do. Okay. I am logged in, apparently. Sign in. All right. I see. I did not destroy the stack when I logged out, so it believes the stack still exists. All right. What I'm actually going to do is I'm going to show everybody the dashboard. There we go. So you can see what you get if you go into the dashboard. So here's the stack that I built that it knows I updated, even though it says it couldn't authenticate me. So I added a README earlier this morning with all of these resources on it. This is all of the metadata as far as what my repos look like. It is tracking my repo. Was not run in an automated pipeline because I don't have one set up for that. I was doing everything manually. Maybe activity. Let's see. List view, stack view. Okay. So let's go look a little bit of live debugging because nothing ever works the first time when I'm on camera. It worked fine last night. Okay. Pulumi. Hello from Minneapolis. I haven't seen all of you in a while, ever since we're between seasons for TikTok. So hello everybody. There will be no Kahoot today, just for the Cloud Chat regulars that you know. Okay, Pulumi. Cannot authenticate. Yeah, that's all I want to do. Pulumi login. Really? I didn't see that command on there, but it's probably no. It's just me. Okay. I apologize, everyone. Oh, right. There we go. Pulumi up. There we go. Create new stack. Yes. Yes, let's update. And now let's go look at our resources. Oh, yep, cloud. There we go. Droplets. Okay, so it updated the stack, but it didn't deploy them. So let's go Pulumi help one more time. Maybe there's a handy dandy deploy. There is not. Refresh and stack. Manage stacks. Up. Pulumi. Nope. Let's see. Schema. So let's see. Did that work? Do they think it worked? I think it's most one resource unchanged because they're talking about the stack. So they do also a resource gives on the resources existing does not give an authentication error. I had the window open since last night, so it probably logged me out, and you do have to hit Pulumi login if you plan to do work overnight. All right, I'll do it. Okay. Hmm. We're just trying to help. I appreciate it. Okay. Export, input, output. Okay. Graph, history, change secrets provider, init, let's output. Now the question is, how can we force it to build? Shows the output. History for the stack. Import from standard. Let's see if I actually just did not do this correctly. Droplets. Did I not wait long enough? Because that's not it. I know that's not it. Okay. This is unfortunate, and we are running up on time. So again, if you can, please tell me if you can see the repo. If you can't see the repo, it will be attached into the tech talk so that you'll be able to see it then. I will put up that bubble one more time because you're a nice audience. I'm not going to make you watch me try to get the authentication to work properly on this. Okay, let's see. Follow along. There you go. So you can try this definition out on your own. It's going to run through that exact same exercise with Pulumi. And then you'll be able to see the stack built in DigitalOcean as well as listed on the dashboard. So the important thing is we need to talk about why they're different now. Just to do a quick overview, the main differences is the declarative one is configuration files, the other one is code. Terraform, you do not need an account to get running. You can run everything essentially either self-hosted and deploying as it is only making API calls. What it does not do is if you are using a cloud provider that has a stack-based system, it will not create new stacks unless you tell it to. A lot of other providers, such as Pulumi, will create its own stack separately so that you can manage it as if it was a vendor native stack. A lot of this depends on how your infrastructure is automated and what your CI/CD environment looks like and who is touching that and how many people are going to be responsible. I talked a lot about state management in groups because that is important, and identity in IAC because that is also important. I'm glad you can. Thank you for being able to access the repository. There is an equivalent of Terraform Destroy. It is Pulumi Destroy. Given the time that we're at, and the fact that I do want to talk more about the conceptual things instead of just watching my stack try to build. We can do this separately. And if you want us to talk more about topics like this and you have more specific questions, feel free to leave it in comments or in chat, and we're always here to help and build more content. But I really want to impress the idea is that the thing with GitOps is that it's not about just the tool, it's about the environment. The way you choose a tool is going to be very dependent on the way your organization is run. Who's doing the approvals to go to do builds, what that process looks like. If you do have an observance tool, I think Terraform might have one. It's either going to be built into cloud or into console. The thing with HashiCorp is that the reason why they are very much a standard of configuration is because they have a lot of products. It's similar to Chef and SaltStack and stuff like that, and Puppet. Depending on what you're using, if you have a similar tool to handle that observance of what your environment looks like and your image registry looks like, and you're able to monitor the changes between both applications and infrastructure, then that is going to determine the kind of the type of IAC tooling that you're going to use. Originally, this was a Kubernetes talk, but the important thing about having this work with Kubernetes is the same thing that's important with general automation, is that there are automation tools that lean very heavily on the declarative side of IAC, where every time it does a change with the environment, that is what is going to measure against, as far as things like scaling and creating new nodes and bringing and doing that type of orchestration. If you have something that's already using a declarative language, the likelihood of you staying in using declarative languages is going to be very high. It's the same thing with imperative IACs. If a lot of your tooling is going to be home built or highly customizable, then chances are you will be pushed very far into the imperative side of IAC, right? So especially if you're going to be, I would look, if you're using this specifically for a Kubernetes setup, go look at what other tooling is available for the way your Kubernetes clusters are deployed, and see what they use. If they lean heavily towards one, for the ease of use of your DevOps and SRE teams, I would kind of stick closer to that. Otherwise, other than this one hiccup here, I actually generally really liked Pulumi because of the state management. Again, my experience with it is not as deep as Terraform, which is why it's a little more difficult to debug, but I feel like the learning curve for Pulumi is not as high. So it's one of those things, if I had maybe another like 15 minutes, I could probably knock it out, but I wouldn't make anyone watch that. But that is going to be the key things in the way you're going to look at automating your infrastructures. Also, because I did watch a video on the Pulumi orchestrating tool. It's called Pulumi Operator. It actually looks pretty easy to follow and maintain. That is coming from someone who does not have to do it. About is how much control you want over your infrastructure. I find imperative languages give you a finer tune of control because you are telling it exactly what order to do things and what to do. That is also possibly programmer bias, where that is the way I like to manage most things that I'm allowed to manage. And are there any other specific questions about this that we can either address right now or address in future content? I do appreciate everyone coming out for this. It is a really big topic. If you want us to do a deeper dive on what GitOps environments would look like, we can do that. Okay, means it's always a chase after the newest feature a cloud provider is offering, and it means a lot of repeating code because Terraform misses control loops. They still don't have loops. I was hoping that would be a thing that was fixed by now. But yeah, if you If you need loops, go imperative, because then you just have the natural ability of whatever language you're using. I forgot that Terraform does not like loops. They really don't. What they have you do is essentially build objects that reference itself, which is dangerous. Terraform is also very AWS heavy. What I found when I was looking through the Pulumi documentations is that it had a wide variety of documentations for different cloud providers. AWS is Terraform treats it always handles AWS first, naturally, because a lot of their customers are on AWS. So if you're not on AWS, even as David, Josh, and on our YouTube chat has mentioned, if you are on GCP or Azure or DigitalOcean, Terraform becomes very difficult very quickly because because it's extremely limited. AWS does have 10 million services, but Terraform also serves them first. So that is an unfortunate case of just the way that, and just what the tooling focus is. Do you have any thoughts on these tools, not only for infrastructure in the cloud, but also internal resources like VMware and NetApp and all the things the typical company's infrastructure? I don't have experience on how they perform for more closed system or on-prem type of systems. I know that they have options for them. I would be very surprised if they would be as fully fledged as they would be for public cloud providers. That said, providers like Red Hat and IBM have a tendency to build their own in-house tooling for this sort of thing. So in the case that you have an on-prem or closed system situation, go with a native tooling set. I think Thomas missed the pun-based cloud chats that we have, but we can't highlight those here. We do not have the time. Kind of what CDK for Terraform was trying to implement seems. Yeah, so the thing with CDK for Terraform is that CDK, CloudFormation and CiviliSAM, if you use it on AWS, they're both imperative. They're both declarative statements, declarative frameworks. You build your config file and it does the thing. CDK was supposed to provide a cloud native imperative solution. It's as long as it's been out and given what its traction is, it's still trying to kind of make that to be as user-friendly as third-party tools have made it. I personally don't think it's there yet, but that's a personal opinion. But I do know a lot of people who are really into SDK, or rather CDK, but they are also going to be less. If you're heavily into SDK, you're going to be less reliant on Terraform, and Terraform is trying to make sure that their tools are compatible with native solutions. For DME or Poem on Twitch, the reason why on-prem use cases tend to be more neglected for the situation, for things like IAC and other tooling, is because the assumption, one, these are considered to be closed systems. It's when you have a closed system, you're probably also dealing with other security and regulation things, where, because smaller and more consumer-based fields tend to be on public and shared services. If you are running strictly in a data center or any other hybrid type of deployment, one, is more expensive, and two, it requires more control. And because of that, the focus for IAC tooling and providers will be public clouds where there is more to abstract, and the entry points into these environments are easier to get to and more public. When you are dealing with a closed system and on-prem architectures, you're going to run into the like just trying to authenticate into your system. Usually usually you're going to go through some type of VPN and some type of bashing or jump server. To do so, they would like providers would generally like to avoid ignore those as much as possible so that they can go directly to the infrastructure. It's easier for the IAC providers to do it that way. And if you're running on-prem or hybrid, the cost of using that type of tool for it is I've seen it happen often enough that the ones who are managing those systems have either proprietary or internally built tooling for it. And that is the way they manage it. They build it directly into their pipeline because they're able to touch every part of their infrastructure without worry. Okay, thanks everyone for coming. Let's see. I don't think I have any slides. No. So all of these links are in the repo that's up. I'll also make sure that the repo is properly shared and reachable on the DO community repo so that you don't have to look directly at my code. You can look at the ones that's going to be shared with everybody. And thank you everyone for coming. Yeah. Again, if there's any more specific and technical questions, please feel free to leave it in the comments, and we will see if it's not a short answer, we'll see if we can do another deeper dive on. We can go deeper on Pulumi if you all would like. We can go deeper on Terraform if you all would like. And we can also go deeper on GitOps specifically and not worry about IAC. It's up to you. Whatever would help you as engineers and developers kind of get to do the jobs that you need to do. Okay. Have a good rest of your week, everyone. And I will see you in the next talk whenever that's going to be, because I don't know my schedule for this month yet. We've been quite busy in the back here. All right, everyone. Have a good week. I will see you later. Bye.